Hi, in this video, we're going to be looking at some historical calculation devices. More specifically, we're going to be looking at the abacus and the lattice method. So back in the day, before they had calculators and phones and things like that readily available, they used other devices like calculators. So vintage calculators. One of those things was an abacus, and an abacus is like it kind of looks like a child's toy to us now, but it's got metal bars and wooden beads with two wooden bases basically, and they used these devices to represent numbers, and then they use those to do calculations. So an abacus is a wooden device, I guess, structure with metal bars and wooden beads used to represent numbers. So they were small, they were handheld. You might have actually seen this. There's an emoji with an abacus. So you might have seen that and gone, what is that? Well, now you know. And I'll show you a picture of it later, but actually I'll draw a picture of it right now. So an example of that is it's got these wooden bases, and then it's got these metal bars, and these metal bars represent place value. And on the metal bars are wooden beads kind of placed throughout here. I'll show you some more specific examples. Oh, and there's a bar here. Sorry, I forgot to say that. And the beads close to the bars represent specific things. So each bar is a place value, and each bead counts for something specifically. So to expand on that, let me tell you what I'm talking about. This will be the ones position, the tens position, hundreds, thousands, and so on. And then the beads are important because the beads above the bar, you're going to multiply by 5, and the beads below count as 1. And that's how we're going to read the abacuses below. Let me zoom out a little bit. So we have this first one. See if you can see it there. Had to zoom out a little bit so that you could actually see it. But we have an abacus here. You can see that it has the bases, it has the bar where we're going to either multiply by 5 or by 1, and each bar is a place value. So if we just write it positionally like we're used to in the Hindu Arabic number system, numeration system, this bead is times 5, and this bead is times 1, for a total of 6 in the ones position. Next one, this is times 5. There's nothing below, so that's just 5. Next one, there's no beads above, so there's no times 5, which means this is 1, 2. On this bar, there's no beads at all, so we put a 0. And then in this position, there's only one bead below, so that's 1. So this is ones, tens, hundreds, thousands, 10,000s. And our number is literally 10,256. And they would use these to do arithmetic. We won't cover that in this lesson, but just to kind of show you how to read an abacus, that's what it is. So for this next one, I want you to pause it, try it, and come back. The number on this abacus is 73. Now, if you want to continue practicing that, I have a website here. This is where I got these pictures, but you can kind of move the beads around and practice reading the numbers on the abacus. Now, the next calculation device that we're going to look at for this lesson is called the lattice method. And this one is really cool. I really love this. Lattice method uses diagonals and addition. Yeah, we'll go with that. Addition to multiply two or more digit numbers. So it's kind of like the box method. If you've ever seen the box method, it's kind of like that, but we take it a little bit further with these diagonals, and it looks like a lattice. If you've ever seen a lattice on like porches or in gardens, it's like little X's like that. It's like that. So what we do here is we set up our two-digit numbers like the box method. I'm gonna have 64 broken up a little bit. You're gonna want some space, and 25. It doesn't really matter where you put the second number, whether it's on the right side or the left side, but usually in textbooks, you're gonna see it on the right side over there, but you're gonna get the same answer either way, so it doesn't matter. Drawing a box here. I have two-digit numbers. And then within those two-digit numbers, I'm going to draw diagonals. Now, for the diagonals on the inside of those boxes, you're writing multiplication. So this is also kind of like doing genetics. You're multiplying 6 times 2. It's also distributive property. We're pulling in a lot of different stuff here. 6 times 2 is 12. 4 times 2 is 8, but I'm going to write that as a two-digit number with 0 at the beginning. Now you go to the second row, 6 times 5, 4 times 5. Okay, I've done all the multiplication. Now I need to start adding. And when you add, we're going to start down here and we're adding along each diagonal. And it might get a little bit messy for a second, but you're going to see where this is going. So on the first diagonal, I just have a 0 there. On the second diagonal, 8 plus 2 plus 0 is 10. I'm going to carry that 1 to the next diagonal. 1 plus 2 plus 3 is 6. And then on this last diagonal, I have a 1. These numbers, orange numbers on the outside, form your answer. 64 times 25 is 1600. Now we have calculators. You could probably do this by hand also, but we have calculators where we can easily check this. So if you're working on the lattice method for the sake of doing an assignment, your teacher's probably going to expect this. But if you want to just check and make sure, you can pull up your calculator, our newer calculators that we have, and use a lot today. And just check your math. We got it right. Look at that. Okay, I want you to try this next one, pause the video, try it, and come back. So at this point, if you've done your preliminary multiplying, we're just multiplying one-digit numbers. And that's what makes this a little bit easier than trying to figure that out traditionally. So 2 times 7 is simple multiplication. 14 goes there. You do that for each number on the first row and then each number on the second row. Remember, on the second row, when it's a one-digit number, you're going to need a placeholder for that first place in the diagonal. Now that we've multiplied, we can start adding down the diagonals. So in the first diagonal, we have a 2. Then we have 15. That means I'm going to carry a 1. That's a 13, 10, 11, 12, 13. Then carry the 1, 4, 5, 6. And then 1. So this number should be 16,352. And then we just write that out. You can always check it with your calculator just to make sure. Okay, last one, 3-digit times 3-digit. Now, if you're doing this by hand, old school way, you're going to have it written out this way, and we're going to have to multiply here, here, and here, and then place value here, here, and here, and then place value. So we're essentially doing that with the lattice method. We are using that distributive method with the lattice method. It's just a little more organized. So I really like multiplying this way if you're going to multiply by hand, especially with large numbers. So anyway, pause it, try it, come back. This one was kind of fun because of the 0 there. It made this whole column zeros, which was really nice. And then this one, again, we had a bunch of zeros here, which made the addition really easy, thankfully. And then when you're adding down the diagonals, just make sure that you double check your addition there so you don't have to carry anything. You should have gotten 377,650. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help. See you in the next one.